So here we go with Chapter 4. Chapter 4 is all on patterns and functions. So we'll call this example 1. What we're supposed to be doing here is we're supposed to be able to represent this information they're giving us on a graph. So the question says a car's speed increases as it merges onto a highway. The car travels at 65 miles per hour on the highway until it slows to exit. The car then stops at 3 traffic lights before reaching its destination. Draw a sketch of a graph that shows the car speed over time. Label each section. So we're going to draw a graph. And since we're talking about speed and time, our two variables are speed and time, we're going to draw a first quadrant graph. And each quadrant of the coordinate plane is labeled, and this one is called the first quadrant. And it's positive x's and positive y's, because time will always be positive and speed will always be positive. Even if you're going in reverse, you're still going a certain speed. Okay, so the car starts and it speeds up steadily until it reaches 65 miles per hour, and then it stays at 65 until it has to slow down to exit the highway. And then it has to stop at a red light and go speed up a little bit, stop at another red light, and speed up a little bit, stop at another red light. So, and then we're supposed to label each section. So this is merging. We'll call this section highway. We'll call this slowing down section exit. And I'm just going to come over here and just draw an arrow to each of these that says stoplight. Okay. Example 2. We want to label the independent and dependent variable first. And that's this example right here where we're talking about the paint in a can. So we're going to paint some chairs, and then we're going to measure how much paint is left. If we don't paint any chairs, we have 128 ounces left. If we paint one chair, we have 98. 2 chairs is 68, and 3 chairs is 38. So we're going to say, what is affecting the other variable? And if you'll think about it, when I paint a chair, I'm using paint. I have to use the paint to paint the chair. Okay? So the independent variable is the number of chairs painted, and the dependent variable is the paint left, because the paint that's left in the can is directly dependent on the number of chairs that I've painted. Alright, and then I'm supposed to represent the relationship using words, an equation, and a graph. First thing I'm going to do is the graph, because it's the easiest. So if you'll notice, it's positive and positive, so we're still going to use a first quadrant graph. And when you count off the hash marks on this graph, you have to count at even intervals. So this goes all the way up to like 128, and then it starts down here at 38. So I'm going to count by 30s each time. 30, 60, 90. Well, let's count by 20s. So 20, 40, 60, 80, 100, 120, 130. There we go. So if I don't use any paint, that's 128 ounces. So 0, which I probably need to count the bottom too, don't I? 1, 2, 3. So 0 chairs is up to 128. It's going to be about there. One chair is 98, so it's almost 100. Two chairs is 68. Three chairs is 38. And that is a linear relationship because I could put a line between those. Then I need to write an equation. So I'm going to say that the paint I have left is equal to the paint I started with minus the number of chairs I painted times the amount of paint I use each time. So each time I'm using 30 ounces of paint, so I'm going to say 30 ounces per chair. And that's my equation. And this equation, if I were to graph this, pretending this was y and this was x, I would get a line that goes through that. We'll call this 3. And we'll call this one 4. The easy way to determine whether a function is linear or nonlinear is to look at the way it changes every time. The y has to go up by a constant rate of change. I need to be adding or subtracting the same thing each time. So for the first one, if you'll notice, it goes from 0 to 1, then all the way up to 8, and then all the way up to 20. So this one's going to be nonlinear. And then this one goes from 0 to 4.5, and then from 4.5 to 9, and then from 9 to 13.5. And if you can't see that that's constant, you could take out your calculator and subtract 9 minus 4.5 and 13.5 minus 9, and you'll see that it is 4.5 each time. It's going up 4.5 each time. So since this one is going up, it's adding the same amount each time. This one is linear. And because this one is not adding or subtracting the same each time, it is not linear or non-linear. Alright, this question asks us to tell whether this is going to be continuous or discrete. So we'll call this 5 and 6. A continuous graph means that if I were to graph it, I would put a line between the dots because it could be any value between the dots. So it's a whole bunch of dots put together is what it is. And a discrete graph is when I could only have this amount or this amount or this amount. So to kind of put that into perspective, a continuous, what I want you to think of is like a bathtub. Okay? And it's got the little faucet that's making some water go into it. Right? The water is continuously flowing into the bathtub. It could have any different kind of amount in it as the water flows into it. So that's continuous. And then there's the discrete. So discrete is, what if I take this faucet away and instead of a faucet I just have a bucket? A certain amount of water goes into that bucket. And that's what I'm filling up the bathtub with. If I put in one bucket, I have 5 gallons of water in the tub. If I put in 2 buckets, I have 10 gallons of water. If I put in 3 buckets, I have 15 gallons, and so on. So discrete is if I have a certain amount that goes in each time. Okay, so number 5, your cost C to buy W pounds of walnuts at $6 per pound is represented. So if I wanted to buy walnuts and they're talking about per pound, I could buy a half a pound or a third of a pound, depending on, I could just buy one walnut, I guess, if I wanted to. So this would be continuous, and if you want to think of it, you've got a bag, and you're filling the bag up with walnuts. Okay, I could put any amount of walnuts in there that I want to make a pound. So I'm going to say that one's continuous. A truck originally held 24 chairs. You remove 2 chairs at a time. The number of chairs remaining after you make T trips is represented by this. You are not removing a half a chair. That's pretty much what you have to think of. Up here, I could have a half a pound. Down here, I cannot take out a half of a chair. So this one is going to be discrete. And this one's going to be continuous. Alright, on this one we're supposed to tell whether each relation is a function. So if we look at number 19, which we'll call number 7. To tell whether it's a function, what you want to do is look at the x values. If the x is different, each ordered pair has a different x, that means that it is a function. So since this goes -1, 9, 3, 5, 9, and these two 9s are the same, this one is not a function. Because the 9s are the same. If I were you, I wouldn't write down the whole problem. What I would write is, for a relation to be a function, the x's cannot repeat. We'll call this one number 8. The x's 2, 3, 4, 5, 6. They're all different, so this one is a function. Alright, we'll call this one 9. We want to evaluate this for x, and I want to do for if x is 2 and for if x is 7. So I'm just going to get rid of these other problems. Alright, so if x is 2, then it's going to be f of 2 equals, and you're just going to replace this x with a 2. So it's going to be 2 times 2 minus 8, which is 4 minus 8, which is -4. If x is 7, so f of 7 is going to be 2 times 7 minus 8, which is going to be 14 minus 8, which is going to be 6. So those are your two answers. Anytime you see the word evaluate, what you're doing is plugging a value in for a variable. In this case, we're plugging 2 values in for one variable. That means I have 2 answers. Alright, for each sequence, write a recursive and an explicit formula. I'm actually not going to have, I'm going to change the directions. I want you to tell me the next numbers. So for 24, we go 3, 8, 13, 18. What's the next number? $23? Good. For 25, -2, -5, -8, -11. What's the next number? -14. Number 26. 4, 6.5, 9, 11.5. What's the next number? $14. And then number 27, 18, 18, 11, 4, negative 3. So I go down 7, down 7, down 7. So down 7 would be negative 10. Okay. Get out a sheet of paper or use the same sheet of paper you're using and number to 10.